Okay, first homework assignment is going to be in 1.6 on finding limits at a point. Now, the idea is kind of cool, but what you actually do is actually pretty easy. Well, it's philosophically easy. All you're going to do is factor and cancel. You did this back in Algebra 1. Now, the problem is, and I'm going to try to demonstrate it by giving you one that's pretty straightforward and the one that's a little more complicated, okay? And then I'm going to explain what's happening, okay? So it's going to be a little weird. I'm going to show you what you do to get the right answer, and then I want to show you what you're actually finding, okay? So just be aware that, oh crap, I realize I'm learning this. I don't need this, okay? Okay, so the process is like this. To find the limit as x approaches 3. Now, here's the problem, okay? Here's the essential problem. If I were to put 3 in here, 9 plus 3 minus 12, and if I were to put 3 in here, I get 9 minus 12 plus 3. Now, what you probably noticed, and if you didn't, I want to make it very clear, oh crap, that's 0. You're not allowed to divide by 0. So now, here's something kind of important. In the grand scheme of things, f of 3 is undefined. You can't put 3 in. Now the question is what's actually happening when 3 goes in? And that's something that's different than you might expect, okay? Because the top is 0. Oh, okay, that is called, when you get a fraction that is 0 over 0, that's weird. But kind of cool weird, okay? This is really important. This is called indeterminate, actually. Indeterminate. I hope I spelled that right. It's indeterminate, okay? And if you remember what I talked about before about calculus being really concerned about dividing by 0, we're going to try to find an answer to this question, even though we can't. Okay, I know that's kind of weird, right? But hopefully at the end you'll see that, oh yeah, I guess that makes sense. What I want to do here is, make it clear you can't put 3 in because you'd be getting 0. So in terms of algebra, does not exist. In terms of calculus, well, here was what Newton said. We could factor the top, x plus x minus 3, x plus 4, and then factor the bottom, x minus 3, x minus 1. And if you remember, you've done this in algebra, so this isn't like a new idea. In other words, algebra kind of leads up to the calculus. We're going to use lots of algebra in calculus. But what we're going to do is we're going to cancel this out. And we're going to just get x plus 4 over x minus 1. And then you can put the 3 in. 3 in, 3 plus 4, and the top 3 minus 1. I'm running out of room here, so I'm just kind of write it over here. 7 over 2, or 3.5. I don't really care which way we write it. So that's the answer. Now, what's actually happening here is kind of important. You know what? Actually, I'm going to save that. I want to do that in the next lesson. Let's just practice getting the answers, and then on the next lesson, I will explain what's happening here. Okay. Now, why did I say that? In theory, this is easy. Just factor and cancel the thing that's causing the 0 over 0. Notice that when you put the 3 minus 3, so what we did is what Newton and Leibniz said is, well, let's get rid of the thing that's actually causing the heartache for us. Now, you might realize something very important here. It's got to be 0 over 0, okay? Right? Because otherwise it's not going to cancel, and we're never going to get an answer. It's always going to be undefined. So here's the weird part. We're going to say that the function value is 3. Is undefined, but the limit is 3.5. So what does that limit mean? What we're saying is, well, okay, I can't actually put 3 in, But what if I get really close to 3? What if I get infinitely close to 3? That's the idea, okay? What if I get infinitely close to 3? And if I get closer and closer to 3, closer to 3, maybe I should, you know what, maybe I should, let me change the green here. Let me explain what's happening here. Just, maybe it is better if I do this right now. Okay. Let me graph them for you really quickly. If you don't believe me, you can put them in your graphing calculator and check it. It's undefined at 1. And it's going to be 0 at -4. And just looking at this fraction here, okay? And then if I go out to infinity, the 4 and the 1 won't matter, and I'll have an asymptotic line at 1. Don't panic if you're not comfortable with the graphing. That's not really the important part here. And so what we would say then is, and then, what if I put 0 in? I get -4, right? So it'll be down here, so. This would be, remember if I put 0 in for x, then the y is going to be -4. And the other graph is going to be over here. Now, here's the thing. That's the graph of this function. Now the other one is essentially the same, except for one important detail, and we need to talk about that. The other one, the problem is when you're at 3, there'll be a hole in the graph. Because you can't put the 3 in. But as I get really, really close to 3, this will get really close to 7/2. So that point there is closed on this one because we got rid of the thing causing the problem. But there's a hole in the graph. And that's what's weird, right? What's weird about indeterminate is just this, okay? What's weird about indeterminate is literally this idea, okay? If it's 0/0, you can cancel the thing causing the 0/0, and it goes to a point that is actually not filled in because you're not allowed to divide by 0, okay? Notice that, so this 0, when I put 3 in, I get 0. When I put 1 in, I get 0, but I don't get 0 in the top, I get 5. That's why this thing breaks up. We know normally dividing by 0, when you divide by 0, you're actually dividing by a really tiny number, right? Think about that. If I divide by 1/10, that's actually multiplying by 10. If I divide by 1/100th, that's actually multiplying by 100. If I divide by 1/1,000,000th, that's actually multiplying by a million. So normally, dividing by 0 means we're actually multiplying by infinity, right? So that's why we go off to negative and positive infinity. Normally, when you're dividing by 0, there's this strange case, and this is what Newton and Leibniz really want to focus on. When it's 0/0, it kind of holds path. Like if you actually graph these, you'll just see a hole in that graph right there that's not on this one, because you can't actually put the 3 in. But notice that on both sides, it's still approaching 3.5. So that's kind of the idea. Now you might go, oh, that's kind of complicated. Kind of let that flow over you. We're going to kind of focus on that for a while. We're going to come and do more examples like this. But notice that in your homework tonight, the basic idea is to factor it and get the answer. Now, so like, we need this to another one here. Okay. So I factor let's factor the bottom. This one here is to illustrate something, you know, pretty obvious. What if you don't remember how to factor that? What if you don't remember how to factor that? Now, let me just be clear about something here. If I put -1 in, remember -1 squared, notice I still get my 0/0. Now here's the key. Here's the key. If you get something like, oh man, I don't remember how to factor third-degree polynomials, because you want to think of that like kind of as, what, 1 to the third, right? So here's the deal. Here's what you're going to do. You're going to go, oh, well, at least I know one thing for certain. since -1 generates a 0, we know from algebra, if -1 generates a 0, then we know that t plus 1 has to be a root. So now I have to get the answer. Now, how am I going to do that? Well, I have to do long division, which is kind of sucky. Now, I know what some of you are thinking. I'll hold that thought, okay? If you do long division, I'm not going to, though. I'm going to use synthetic division. Now, if you don't remember how to do synthetic division, you're going to have to do long division, but then synthetic division is pretty simple. You drop the 1 down, and then you multiply. You add, and then you multiply. You add, and then you multiply, and that better be 0. And then you just reduce the power by 1. So this is t squared minus t plus 1. So this is t squared minus t plus 1. So then this cancels. Remember, you got the whole point here is to do, every question is kind of like this. You do something to get something to cancel so that you can actually put the 1 in without getting this indeterminate idea, okay? So then what you're going to do here is put that -1 in, 1 plus 1 plus 1, -1 plus 4, 3 over 3, oh, that's 1. So that has a limit of 1. Now keep in mind, it has a function value that does not exist. You can't actually put -1 in here. But what we're actually doing here is we're saying, well, what if I get really close to -1 but never touch -1? It's going to keep getting closer and closer to 1. But then there's a philosophical discussion. You know, what else should go in that open dot that's not filled in, right? So that's the basic idea in your homework, okay? Now, obviously they get more complicated than these. Hopefully when we start working on the homework on Thursday or Friday, you know, if you have questions, you can ask me. But that's the basic idea. Is you're going to have things that are 0 over 0, which are going to create holes in these functions. The other ones, of course, are going to be straight up and down, or have vertical asymptotes, which normally happens when you divide by 0, right? What we want to do is what we're trying to do is trying to find where would that hole be in that function. What's the actual y value for that? Okay, so we know the x value, and then what is the y value, and that's basically what you're going to be doing in your homework. Okay, thank you.